Okay, so let us start. This is the second lecture. So we discussed in first lecture regarding our collision, and then we came across one of the most important terms. We call it as like coefficient of restitution, isn't it? And that used to give us an impression what actually happens. And we talked about a lot about that. Then we got to know that in between that when there is a collision, and that impact where the when the impact starts, that impact is of two phases. One is deformation phase, one is reformation phase, and we wrote the impulse relation for the deformation period and for the reformation period also both. But we got to know that if we write the impulse relation period, then we got to know around our one quantity which says that whatever happens, initial momentum is equal to final momentum if net external force initially is zero. Are you able to get me or not? And that was, this is called as, basically this is known by the name of law of conservation of momentum. Okay, and then to talk in a much more greater sense, as we know that how the collision has occurred means what is the aspect of collision we want to know means कैसा collision हो रहा है. So we got to know, we brought one term which we call it as coefficient of restitution, which used to tell us that how much reformation is there after the deformation. Are you able to get me or not? And that is related because since the impulse is only the factor which is creating reformation and deformation, so that is why we take the ratio, and then we talk about the geometrical shape and size of the body after the collision. Are you able to get me or not? So let's suppose just if E is equal to 1, that implies impulse of reformation is exactly equal to impulse of deformation, means whatever happens the body is fully recovered after the collision. You can see, like, let's suppose if you just collide two balloons, it will what it will happen, they will collide, they will change their geometrical object, but as soon as they get separated apart they will once again regain their shape, isn't it? Next point is to understand in a much more greater sense. We brought this impact phase and the condition over here. So we know that for the reformation, velocity of B should be greater than velocity of A. Then only the reformation happens. And this velocity appears due to the impulse of reformation, not information. Okay. Okay. Is that clear? Are you able to get me? Okay. So to have a greater sense, the first case means we want to discuss about the case about this coefficient of restitution. So the first case we picked up was when velocity of A is exactly equal to velocity of B. So that means it implies that when these velocities are equal, that means they are actually taking forward this impact phase, which means that they have stuck together and then there is no impulse of reformation over there. Means the bodies have fully deformed. Are you able to get me or not? So basically, to have to understand this particular condition, that what happens to the reformation, we talk about coefficient of restitution, and as coefficient of restitution is impulse of reformation by impulse of deformation, and impulse is nothing but the change of momentum. Like over here, impulse is nothing but change of momentum. We bring this as coefficient of restitution as velocity of separation by velocity of approach, because impulse of reformation means velocity of separation and impulse of deformation means velocity of approach. Is that clear or not? Okay, so first thing is E is always a positive quantity. Second thing, it must lie between 0 and 1. ठीक है, मतलब छोटी छोटी बातें, जैसे मान लो कि जैसे हम क्या करते हैं, हम मतलब पेन वगैरह खरीदते हैं ना, तो अब एक काला पेन है, एक रेड पेन है, एक ब्लू पेन है, ऐसे बहुत सारे पेन होते हैं, है कि नहीं? अब हर पेन का अलग अलग प्रॉपर्टी है कि नहीं? लेकिन एक 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 ऐसा आता है ना, एक बंडल बंडल ऑफ पेन्स जिसमें बहुत सारे कलर्स होते हैं. तो वैसे ही coefficient of restitution is a bundle which talks about that how the impact is happening and how the bodies are reforming after the collision. Are you able to get me or not? Okay. And in that bundle we have three different values and we'll talk about that. So first one is, let's suppose we got to know about velocity when they will stick together. Second thing is, let's suppose what happens if the E is less than 1. So we talked about first case, which is E is equal to 1. Then this is the case when they are sticking together, means there is no impulse of reformation. So that means only one thing, that E value is 0 because impulse of reformation is 0 over there. Are you able to get me or not? So we got to know that this E value must lie between 0 and 1. Are you able to get me or not? So the question is, what is there if E lies between 0 and 1? So E is less than 1. So that means that velocity of separation is less than velocity of approach. Is that clear or not? So this is why these are appear. Okay, and that means that impulse of reformation is less than impulse of deformation. Means the body after collision are slightly deformed. Is that clear or not? Are you able to get me? Now, so we talked about all these cases: E is equal to 0, E is equal to 1, and all these. Okay, so this was E is equal to 0, this was E is equal to 1, and this is less than. But let us come to talk, have a greater means this E is equal to 1 and E is equal to less than 1 is not a big issue. But the question is about this E is equal to 0, exception in E is equal to 0. E is equal to 0 means what? No impulse of reformation, isn't it? Now, what we talked is like if E is equal to 0, no impulse of reformation is there. That means that the bodies will stick together. Are you able to get me or not? This was our conclusion. But this is always not true. This condition is always not true. This is a misconception. Are you able to get me or not? Not like right, always not true. This is a misconception, just in a simple term. That they will stick together. Yeah. Sometimes means E can be 0 also. We'll see. You will see about that. Okay. So, we'll talk about this. Let's suppose I'll take an example of that. So let's suppose the bodies are moving in this line. Okay. I'm drawing the diagrams beforehand only. Okay. So let's suppose one ball was moving in forward direction and one ball was moving in, or you can say it was at rest over here. Right or not? When they collided, what will happen? This starts to move along this direction, and this starts to move along this direction, isn't it? Are you able to get me? Okay. So look over here. This body was moving in forward direction with some velocity v naught. Okay. So what we observe after collision, that they are moving in this direction. Why? Because the normal lies in this direction, isn't it? Correct. If you see in the normal, the contact is like this. So the normal is along that way, isn't it? Now look over here. If we talk about the velocity of the first ball, this was along this side, which was v naught, isn't it? Now this v naught will have two components now. This v naught will have two components, one along this side, another along this side. Are you able to get me? isn't it? So let's suppose means I'm just considering that they are making some angle theta at this instant of time. So this is V naught sine theta and this is V naught cos theta. Look over there. Are you able to get me? So look over here. Will if we try to see this is block A and this is block B. Are you able to get me or not? So look over there. If we want to talk about the velocity components or something like that, so let us just try to understand. If A and B are there, so we can say that after collision, V naught, or you can say V naught sine theta was the component along the line of V naught cos theta was the component along the line of sorry, so V naught correct. So V naught sin theta is the component along perpendicular direction of, yeah, line of impact, and V naught cos theta is the component along the line of impact. So the first task is to understand what is this line of impact and what is this line of uh, impact. So there are in collision we define there are two kinds of line. One we call it as line of impact and another one we call it as line of motion. Okay, line of motion means the line which the bodies are following for motion. Okay, which bodies are following for motion. Second point is what is line of impact. This is the line which the bodies experience the norm. क्या है ये लाइन ऑफ इम्पैक्ट? क्या है कि ये वो लाइन है जिसको नॉर्मल जो जो कि बॉडीज फॉलो कर रही है नॉर्मल के लिए. आर एबल टू गेट मी और नॉट? Is that clear? So means whenever see that, try to understand. Like in these motions, you see that this is the line of motion. Okay, and in the same direction, the line of normal is also present. Are you able to get me? So basically, this is why they are called means, or we can say that this is that in which we have the parallel line of motion and line of normal. Are you able to get me or not? Is that clear? And here, in this case, we have a different because this is my line of motion. Okay, while this is my line of impact because in this line our normals are present. Are you able to get me or not? Is that clear? So now let us talk in this greater sense. Uh, we have the line of impact and we have the line of motion also. Are you able to get me or not? Now try to understand what actually happens along the line of impact and what happens along the line of motion. Can you see any difference over here? Mhm. So, so any kind of can we have any kind of conclusion regarding this? Now let us think of one case. We know that if E is equal to 0, if E is equal to 0, then the bodies will move with, try to understand, the bodies will move with the same velocity, isn't it? Look over here. Like here, if E was equal to 0, if there is no impulse of reformation, if E is equal to 0, then the bodies will move with the same velocity, isn't it? यहाँ पे भी तो वही है ना. Look over there. If we look into the momentum along the line of impact initially, there was no momentum in that. Initial momentum was not present over there, isn't it? So if we have over here, let me just minimize this. Let me talk in a crude sense that if we can see along the line of impact, then what do we observe? That for E is equal to 0, the bodies need to have the same velocity along the line of impact or not, isn't it? Remember, the bodies have same velocity along the line of impact if E is equal to 0, isn't it? ध्यान से देखो, bodies have same velocity. That means this velocity of this body which is present as v naught cos theta must be provided to this, and that will, whatever happens, we will take care of that after some time. But the condition is that the velocities must have the same velocity along the line of impact if my E is equal to how much? 0. Is that clear or not? So the condition is, people used to say that if E is equal to 0, the bodies will stick together. But what is happening over here? If you see clearly, this component V naught sine theta for the other body takes the body away out of contact from the another body. Look over here. This V naught sine theta component of this body, isn't it is taking this body after the collision? Isn't this component V naught sine theta is taking the body away from this body or not? From body B, isn't it? So this is why I said that although look over there, although their E is 0, although their velocity along the line of impact is going to be same, but this component of V naught sine theta is taking the body away. That means what? The bodies are not stick together, isn't it? This implies that although E is exactly equal to 0, but the bodies are not in contact. Are you able to get me or not? So this was our biggest misconception, that if E is equal to 0, that implies that bodies will be in contact. But that is not true. If E is equal to 0, we might see that some bodies are not in even contact, and that kind of motion is also possible. Here E was given as 0, so their velocities become same, but along the line of impact. But one body was carried away to the other side with the help of V naught sine theta. Are you able to get me on? Is this clear? So we got the conclusion that we have coefficient of restitution. It talks about two to three important things. First thing is it is equal to impulse of reformation by impulse of deformation. Second point is, acha, this is equal to velocity of separation, that is Vb minus V of A divided by U of A minus U of B. Are you able to get me or not? But this thing must be along the line of impact. Because impulse is only carried away along the line of impact. Are you able to get me or not? Is that clear? Next thing, if we have these conditions, then E has three different values. E is equal to 0. That means no impulse of reformation. That means bodies after collision moves with same velocity. Isn't it? Second point, E is equal to 1 implies impulse of reformation is exactly equal to impulse of deformation. And this implies that bodies after collision gets fully recovered. So now look over here. So we have these conditions, and impulse E less than 1 is a general condition which we will have to always talk depending upon the situation. Are you able to get me or not? So based upon these all three things, we discuss about our topic collision today. Okay, let me just minimize it already. Uh, 1 minute. Yeah, 1 minute. Bro. Yeah, let me just talk about initially. Then we will minimize it maximum. So we have the collision, and that collision which we have is going to be talked in five different ways. Okay, so let us talk about that. Hmm. Okay, so first, let us talk about our main two different kinds of collision. Okay, the first one we call it as head-on collision. Okay, and the second one is called as oblique collision. So we have total five different types, but the head department is these two, which we call it as head-on collision and oblique collision. Are you able to get me or not? So let's suppose if we have two objects which are moving in same direction. Okay, so let us talk about that first. So try to see. Okay, 1 minute. Okay, so let's suppose what happens is if the bodies are moving in such a way that this is their, let's suppose if they have some velocity, this will be their line of motion, isn't it? So बोलो हाँ ना, let's suppose this is body A. Yeah, this is body B. This one was moving with the U of A. This is moving with the U of B. So we call this as line of motion. Similarly, for these two bodies, what we can observe, this is their line of motion only, isn't it? Are you able to get me? Now let's suppose if they have some velocities in equal and opposite direction, u of a and b, u of b. Now when they will collide, what will happen? Let's suppose they got collided. You will see that the normal which is bound to be created for these two bodies, they are present in such a way that they are parallel to the line of motion itself, isn't it? कुछ तो बोलो हाँ या ना. So you see that what has happened, the line along which the both the normal are present, we call it as line of impact, isn't it? So what do you observe? So head-on collision is that collision in which line of impact is similar to line of motion. No, we have to say similar to line of motion. Okay, is that clear? Along is a different word. Both are similar. Is that clear? Now, what happens in oblique collision? Let us have a talk regarding that. That when they will collide, okay, when they are going to collide, what you are going to observe? That let's suppose they got collided. What you are going to observe is there for them the line of impact is actually not in the same direction which we were having as line of motion. So this was my normal line. This is my normal. So this is my line of impact. So oblique collision is that collision in which you will see that the line of impact makes some angles with line of motion. अरे मेरी बात क्लियर हो रही है? ठीक. So based upon this, we consider our means our collision. In now this was according to their movement. Now it will come. Now the division of collision is on the basis of what? Coefficient of restitution. Okay. So now let us put collision, and we have such three different kinds of collision. Okay. We will talk about the third one later on. The first one is called as perfectly elastic. Yeah. This is called as perfectly inelastic. And the last one is called as inelastic. But first we will talk about perfectly elastic and perfectly inelastic. Are you able to get me or not? Let us just have a talk. The talk is very simple. Let's suppose there are two bodies moving, then they got collided. Sorry, they got collided. They once again they got separated. Okay. Similarly over here, there were two bodies moving in same direction. They got collided, and then they once again got separated. Are you able to get me or not? Let us have a talk regarding this. So we have 1 minute. Let's suppose there were two bodies which were moving with some velocities. Okay. and then they got collided. So if they will collide, what will happen? We know that, sir, कुछ ना कुछ तो होगा ना, है कि नहीं? तो हम उन्हीं के बारे में बात करेंगे. तो जब ये कोलाइड किए, लेट्स सपोज दे गॉट कोलाइडेड ओवर हियर, and then once again they got separated. What you are going to observe then? Tell me. What you are going to observe? That, let us see. So let's suppose the bodies were having initial velocity A, initial velocity B. Okay, they got collided, and as we know that if they are getting collided, the normal will be present. So I'm not drawing the diagram of oblique collision. I'm just drawing the diagram of head-on collision. Okay. So they got collided and the normal are present in this direction. What you will see that finally these velocities are v of A and v of B. Now you will see one of the most important thing, that when it is a perfectly elastic collision, then these bodies which have appeared after the collision, they are fully recovered. What they are? Or fully reformed. Then we know that if it is a fully reformed body, for that E must be equal to how much? 1. E must be equal to how much? 1. So this is what is there. This is my velocity of separation, Vv minus V of A. And this is my velocity of approach, UV, U of A minus U of B. Isn't it? So if it is a perfectly elastic case, then the bodies gets fully recovered, and these velocities Vb minus V of A is exactly equal to U of A minus U of B. Are you able to get me or not? So does that implies that if they are fully getting recovered, then whatever is the initial kinetic energy of the body, since there is no change in the momentum, initial kinetic energy must be equal to final kinetic energy also. Is that clear or not? So, if we discuss about perfectly elastic collision, this is what happens, that all the bodies gets fully recovered. E is exactly equal to 1. And this implies impulse of reformation is exactly equal to impulse of deformation, and that makes the kinetic energy initial to be equal to kinetic energy final. Are you able to get me or not? Let us just talk about this case of perfectly elastic collision. The bodies got collided. The bodies were moving. Okay, I'll just draw a little bit nearer and nearer. Okay, they got collided. Okay, what happens after collision? That they got separated. Yeah, there is. They got separated, but with some deformation, or we'll see that. So what happens? Let's suppose this is my one of the body, another body, U of A, U of B, U of A. So velocity of approach was U of A minus U of B. Are you able to get me or not? Now they are coming together. What happened is they got collided, and when they are getting collided, the normal acts in, you know that in which direction, backward or forward, whatever you see. Okay. For body A and body B both. But one thing was quite clear, that after collision, they didn't got separated. They are still moving with same velocity v. So this phase is not required basically. They are still moving with which velocity? V, which is common to both. So that means if it is common to both, then impulse of reformation is exactly equal to how much? 0. Is exactly equal to how much? 0. That means V of A is exactly equal to V of B, which is equal to V. Are you able to get me or not? So now, if you look over here, in this case, initially the bodies were having different velocities, different kinetic energy. One was having maximum, another was having little bit less minimum. But when they have common velocities, what do you see? That this implies that E is exactly equal to 0 because of this case. And this implies one of the most important case, that kinetic energy final is basically less than kinetic energy initial. Why? Because finally they have the common velocity. No one is having maximum velocity or minimum velocity. Are you able to get me or not? So this is that case where we have the maximum loss of kinetic energy. In first case, there is no loss of kinetic energy. But in this case, E is equal to 0, maximum loss of kinetic energy actually happened. Are you able to get me or not? So this is the biggest difference between E is equal to 1 and E is equal to 0. Are you able to get me? Now let us talk about third case, which we call it as inelastic collision. Just inelastic collision. Are you able to get me or not? So what happens once again if we have two different bodies? Oh, okay. So let's suppose they are moving. They are moving with some velocities and all. थोड़ा बड़ा कर दिया ना. They got collided. Deformation happened, isn't it? And after deformation, they got start to get separated. When start to get separated, we'll see something. Let us see that. So we know that they still have, this is A, this is B, then they have common normal, and then this is moving with some velocity. This is moving with some velocity. So look over here, this is A, U of A, this is B, U of B. This is my normal. Are you able to get me or not? Okay. Now finally, they have A, V of A and V of B finally. So velocity of separation is once again V of B minus V of A. Then velocity of approach is U of A minus U of sorry. Correct. So inelastic is that particular collision in which E is basically less than 1. So that means here what actually happens due to this normal, there is an deformation. This deformation is more. Are you able to get me or not? Due to which what actually happens over here? The reformation is very less, and due to this, what actually happened, that we get our final kinetic energy to be actually less than initial kinetic energy. Are you able to get me or not? Why final kinetic energy is still less? Because there is due to the loss of energy, because the deformation is still present. So some energy is lost during that deformation. Are you able to get me or not? So that is why kinetic energy final is less than kinetic energy initial. Are you able to get me or not? Now, in all of these kind of collision, one thing is very common. सब में एक चीज बहुत बड़ी कॉमन है. क्या है कॉमन? कि सर जब भी हम बात कर रहे हैं इन सारे चीजों के बारे में, एक काम करते हैं, थोड़ा इसको और छोटा कर देते हैं. नो इट्स नॉट गुड. Yeah, let me just put it away. So let us, when we talk about all these collision, we see that the F external on all of these is basically how much? Zero. How much is that? So if F external is zero, it actually means, yeah. So whatever is this case, in all of these case, one thing is there, that your initial momentum is always equal to final momentum. Is that clear or not? Are you able to get me? That is perfectly elastic, inelastic, or whatever it is. That one thing is very, very common, that initial momentum is exactly equal to final momentum. Is that clear? Is this clear or not? Okay. So now let us have a little bit of conclusion or something like that. Or there are some questions. We'll start solving some questions. Okay. So do it. Let's suppose there are two bodies. Okay. I want to change the background. I want a line background, or yeah, grade one is good. No, line one is good, isn't? Or grade one. Line is good. Yeah. Black line will not be there. So let's suppose I have two balls moving in opposite directions. Okay. One with velocity v, another with velocity twice v. One has mass m, another has mass twice of m. Okay. Question is, if they collide elastically, then find, if they collide elastically, then find the velocities after collision. Then find the velocities after collision. Do. Put out. What is the velocity after collision? Okay, let us suppose after the collision, the bodies are moving with some velocity. I'm just taking the random direction. Okay, this is velocity v dash, and this is velocity v double dash. Okay, m2. Is that clear? So you know that when there is a elastic collision, E is equal to how much? 1, isn't it? Now, if E is equal to 1, then you have the relation that velocity of approach. Okay. Uh, let's suppose I call it as I'm taking left side as positive and right side as negative. Are you able to get me? So if left side, okay, let us make our same convention. Right side as positive. So what it will be? V double dash minus of minus V dash. So it will become plus V dash, isn't it? Is exactly equal to velocity of approach, that is v of a, v minus of minus 2v, so which is plus 2v. Are you able to get me or not? Is that clear? So this is how I'm writing. You see that always I'm writing, let's suppose if this is a and if this is b and this is a, this is b only. So you have to always take that configuration always. That velocity of separation is v of b minus v of a. Okay. While velocity of approach is u of a minus u of b. Are you able to get me or not? So this is our case. So that means we got our relation v dash, v double dash plus v dash is equal to how much? Thrice v. Are you able to get me or not? Now, this is the elastic. This is first case, first condition. Now we also know that momentum is also conserved over here, isn't it? If momentum is conserved during this process, then it is quite simpler that initial momentum is exactly equal to. So that means, let's suppose if I bring initial momentum, means initial momentum is mass into v minus of twice m into twice v, isn't it? Must be equal to final momentum, which is minus of mv dash plus of twice mv double dash. Are you able to get me or not? So we got this relation that twice mv double dash is exactly equal to sorry, minus mv dash is exactly equal to this is minus of 3 mv, isn't it? So m got cancelled, and twice v double dash minus v dash is equal to minus of thrice v. Are you able to get me or not? Is that clear? So let's suppose if I just solve this equation, what we got, v double dash plus v dash twice v double dash minus of v dash is equal to here 3v, and it is equal to here minus of 3v. Are you able to get me or not? So so that means v double dash is how much? Yeah, v double dash is how much? 0. So what is about v then? V dash. So v dash is going to be equal to how? So v dash is equal to how much? 3. So that means that after the collision, 2m stops. This means twice m stops while m moves with 3v velocity in backward direction. Is that clear? Are you able to get me? Now let us take one more example. Let us take the example now. Let's suppose you have a big wall. Okay, so there was a big wall. Got it? And in front of it, a ball was moving. Got it or not? So this was my big ball, and in front of it, some ball was trying to move. Now, one of the most important generalization I want to give about big balls. Okay, people think that big balls means simple concept, but actually you have to very cautious when dealing with big balls. Try to understand. Let's suppose if I just told you that this ball was coming towards big ball and the ball was also moving with some velocity. Yeah, this was moving with velocity 10 meter per second, and the ball was moving with velocity 5 meter per second. Okay, treat this as A or just our normal convention. This is A and this is B. Are you able to get me or not? But it was told that the coefficient of restitution, the coefficient of restitution between the wall and ball is 1 by 2. Okay, then find the velocity. Then find the velocity of ball after collision. बताओ. Okay, one most important case you need to understand. Whenever this kind of question appears, a wall or a big object or something like that, whenever there is a object, whenever there is a grammar big written over here, that means the velocities of these objects never changes. The velocities of these objects never changes. Okay, this is a big wall. Its velocity can't be changed because it is already moving with some other velocity. Are you able to get me or not? Okay, so apply that concept into this problem. It is going to be exactly the same. So once again, I'll mark it. If this is B, this is A. So one thing is done here. Yeah, minus 20. No, do it once again. Think about the case. The wall velocity never changes, which is 10 meter per second, isn't it? But this ball A, what about this ball A? Mm-hmm. I don't know. Let us consider that it was moving in the same direction. We'll get, yeah, let's suppose if it is moving in same direction. So it is V of A, isn't it? This is V of B. This is U of A. And this is U of B. So what is the relation? E is equal to what? Simple velocity of separation, which is what? VB minus V of A, isn't it? Divided by U of A minus U of B. So what is VB? VB is minus 10 minus V of A. U of A is how much? 5. Minus of minus 10 is my U of B or not? So 1 by 2 is equal to minus 10 minus V of A divided by minus 15. How much is that? Minus 15 by 2 is equal to minus 10 minus V of A. Are you able to get me or not? Hey, 1 minute. Why minus 15 I have written? Plus 15, plus 15. Sorry. Is that clear? So how much is that? Simple. V of A is equal to 15 by 2 plus 10, which is minus 15 by 2. Oh no, it is plus minus V of A. So that is 35 by 2, isn't it? So that means what? V of A is equal to minus of 17.5 meter per second. That means it is actually going opposite with an increased velocity, which is how much? 17.5 meter per second. Are you able to get me? Is this clear? Hmm? Let us take one more example. Hmm. Big wall. Okay. And a ball is approaching this wall. Got it? This ball is approaching in such a way that, try to understand, its velocity is along this line. Okay, are you able to get me? So its velocity along this line is somewhere 10 meter per second. This is A, this is B, and the wall is moving upwards with a velocity 10 meter per second. Are you able to get me or not? Same, 10 meter per second, 10 meter. Yeah, yeah. So the angle, and it is also given that the angle of inclination over here is basically 37 degree, and E between wall comma ball is exactly equal to 1 by 2. Then find velocity of ball after collision. बताओ. जल्दी से बताओ. बताओ जल्दी से क्या हो। You are getting how much? Silly mistake. There is a little bit. Check once again. Check it once again. Okay, let us see now. Try to see. Okay. So we have this is 10 meter per second. First, let us try to resolve this. This is going to be also 37, isn't it? अरे कुछ तो बोला हाँ है ना? So this is going to be how much? 10 sine 37, and this is going to be 10 cos 37, isn't it? Let us just make this clean. So 10 tan 10 sine 37 means how much? Sine 37 is 3 by huh? 3 by 5. 5 to the 10. So this is 6 meter per second, isn't it? And this is 5 to the 4 to the 8, 8 meter per second, isn't it? Now look over here. When the bodies are colliding, then there are two things. One is line of impact and one is line of motion, isn't it? Which is my line of impact? When the body, when this body appeared over here, this is B, this is A. So where is my line of impact? The line of impact, try to understand. When it is colliding, many people will think that the line of impact is this, but the answer is not true. The line of impact is still vertical because one of the bodies is big wall is vertical. Is that clear? This is my line of impact. Are you able to get me or not? So look over here. For this ball, which has the velocities, two velocities were there, isn't it? One, when it is colliding, I'm just drawing that. There were two velocities when it got collided. This was total 10 meter per second. This was 37. So this was 6 meter per second. I'm just taking the conclusion of this, and this got to be 8 meter per second, isn't it? And the ball was moving with velocity 10 meter per second. So conclusion is very very simple, that whatever is the velocity along the line of impact, that velocity is only going to change, isn't it? Because impulse only acts along the line of impact, so velocity along the line of impact will only change, will only change. So this velocity of 6 meter per second is never going to change. Are you able to get me? So when the ball started to move from here, one velocity component we got to know is that it is 6 meter per second after collision of the ball A, even though the ball was moving with 10 meter per second. Are you able to get me? Is this clear? So it is 6. So what is the condition? I have to find just the, let's suppose this is ball A. So V of A, I have to find, isn't it? And remember that this coefficient of restitution formula, whichever coefficient of restitution formula, if we know that this is only along the line of impact, isn't it? So we have to only take the velocities along the line of impact. So this 8 meter per second, I treat it as velocity of A, U of A, and this 10 meter per second is U of B. V of B is still same, which is 10 meter per second in forward direction. Are you able to get me or not? So if I apply the coefficient of restitution formula, E is equal to, we know that V of B minus V of A divided by U of A. So what is this? V of B is 10 upwards. V of A I have to find out. V of B, U of A was given minus 8 because it was downwards, isn't it? Oh, and then what is that? Minus of plus 10. Yeah, correct, correct. And E is equal to how much? 1 by 2. So if we got our relation that 10 minus, yeah, it should be minus 9. So V of A is equal to 19 meter per second. So this is 19 and this is 6 and this is 19 meter per second. So resultant velocity is root over this value. Are you able to get me or not? You'll have to calculate, and this angle theta with which it is projected now can be easily written. So tan theta is perpendicular 19 by 6. So theta is tan inverse 19 by 6. Are you able to get me? Is this clear? Write this, then I'll move ahead. Okay. Now, look over here. Let's suppose I have only three colors are there. Okay. I have a ground. Okay. I think the line was good or this one is good. The plain white paper or line one? Okay, let us put the line one. Okay. So let's suppose I have a ground and a spherical ball is falling on the ground. Okay. Okay. Let's suppose the ball starts to fall with some velocity v naught towards the earth. Okay. Means towards this ground surface. Okay. Means I'm just talking, means this velocity v1 is attained after traveling height h. Are you able to get me or not? So it is just released from here. Let's suppose I just release it from here. Sorry. Let's suppose this ball was released from here, and let's suppose the coefficient of restitution between the ball and the ground is given as E only. Is given as how much? E. Are you able to get me? So the question arises that if it travels height h, if it travels some height h, then find the velocity of ball after collision. without. Then find the velocity of ball after collision. Hmm. Then find the velocity of ball after collision. You think, you think, what is that? Think. Okay, now look over here. See that. This is A and this is A itself, isn't it? This is B. Whatever happens, ground is there. So velocity of B is always how much? Zero, isn't it? So here I'll write U of B is equal to zero. V of B is also equal to how much? Zero. But there is a twist. Actually, for U of A, you do not have to consider 1 minute. Let me erase this thing over here. Actually, it should be brought over here. Control C, Control V. This ball, actually, if you want to consider, because the ball attains the velocity just before hitting the ground, isn't it? And that is my U of A, which is exactly equal to root under 2G H. Are you able to get me or not? Is that clear? Now I'm asking that what happens to this? So velocity of A I need to calculate after the collision, isn't it? So let us put it in the equation. We know that E is equal to V of B minus V of A divided by uh, U of A minus U of B. So V of B is 0 minus V of A I have to calculate, isn't it? Divided by U of A, which is how much? Only root 2gh. It is in downward direction, no? So minus root 2gh, isn't it? Minus of 0. So that is why V of A is E times root under 2gh. Are you able to get me or not? Isn't it? So actually the ball which came and which hit it, it has means you look over there. E lies between here. If it is not elastic collision, we know that E lies between 0 and 1. So that means V of A after collision is less than the velocity just before the collision. Just before the collision. Are you able to get me or not? So can you just find that how much height this ball will rise up after the collision? Let's suppose this is new height, it will rise or not? H dash. So what is H dash? So we know that at the top of height, the velocity becomes how much? Zero. Yes. So the equation is simple. VA means V final square, velocity at the final position, is equal to initial velocity square plus 2gh. यही है ना फॉर्मूला? 2gs 2as ऐसा लिखो. फाइनल वेलोसिटी तो जीरो हो जा रही है, तो जीरो स्क्वायर इनिशियल वेलोसिटी कितनी है? इट इज e इंटू रूट टू जी एच. सो e स्क्वायर इंटू टू जी एच. आर एबल टू गेट मी और नॉट? प्लस एक्सेलरेशन नीचे है तो माइनस टू जी इंटू हाइट न्यू विच इज एच डैश. आर एबल टू गेट मी और नॉट? So look over here. H dash is how much? It is E square times H. How much times H? E square times H means after every successive collision, the height is going to reduce faster rather than even velocity. Is that clear or not? Is this clear? So we are going to pick this up. We are going to pick this fully. Means we are not going to stick to this only one or two types of problem. We are going to have a different kinds of conclusion regarding that, what actually happens and how it happens, and then we'll talk about some of the tedious problems, what actually happens on the wall, what actually happens on the bus, what actually happens with the projectile colliding with each other, and all these kind of things. Are you able to get me or not? But I want you to do the calculation of this, like even for this thing, the time period equation and all those kind of things, and then we'll move ahead. Are you able to get me? Okay, so let us just have a time period calculation also. We have some 10 minutes time. So let us just see. A minute. Um, where is that? जा. एक मिनट रुक जाओ. Sorry. Hmm. So just tell me that if there is a consecutive bounce, then for how much time it was in the time of flight? Find the t dash. Find t dash. Hmm. You have to find t dash. सृष्टि एक काम करेगा. तुम्हारा एक मिनट. ओके, फर्स्ट फाइंड टीडस एंड देन विल टॉक अबाउट दैट. ओके, जस्ट फाइंड टीडस. Okay, so let us do this first. Try to understand. See, जब बॉल रिलीज हुआ तो कुछ ना कुछ टाइम लेगा वो फॉल करने में ना. तो टाइम ऑफ फॉल पहले तो निकालना जरूरी है. फर्स्ट इज टाइम ऑफ फॉल विच वी कॉल इट एज टी. ओके, तो कितना है ये टाइम ऑफ फॉल? नथिंग बट रूट अंडर ट्वाइस एच बाई जी. यही होगा ना. हमें निकालना है टी डैश फॉर हाउ मच टाइम. सो सिंपल, वंस अगेन वी कैन अप्लाई for the second case. V final is equal to U initial plus 80 है कि नहीं? V final है क्या? 0. U initial we got to know that is with which velocity it is going up, E into root 2 GH minus G into T dash new time. Are you able to get me or not? So what is this relation? T dash is equal to E into, once again it is root under twice H by G, isn't it? So look over here, this T dash is nothing but A into the initial time of fall or not. So see, you got the relation. The first relation is, this was, this can be even written as E into V naught. Are you able to get me or not? So we got the velocity equation that just after collision, the velocity changes as E into V naught. But the displacement changes as E square H naught. And time of light changes as E times original time. Are you able to get me or not? And they basically increase in their orders. So their increase in orders for the next successive collisions, we will also talk about that. But that we will talk tomorrow. Is that clear or not? Okay, be over here. Just 1 minute. Let me stop this recording.